Hello everyone, I'm here for Lab 4 circuits, and this is for Physics 2, and my name is Alfonso Verde. So this is my second time through it, but we'll get it done, hopefully faster this time. So, introduction. The purpose of this lab is to predict the behavior of circuits, resistors, and capacitors, and the circuits are constructed with either parallel or series resistors, and we measure that behavior by looking at the current and the potential. So, models and principles. The model in this experiment is quite literally the items that we had around us. We didn't use any online models like in the past. So Kirchhoff's rule, or here's some principles that we use for the experiment. We have Kirchhoff's node rule, which is that the current in is equal to the current out of nodes, which is just conservation of charge. We have Kirchhoff's loop rule, which is that voltage of the ith like node, we'll call it, plus, easier way of saying this, the summation of all the nodes in a loop will be equal to 0. Of all the voltages of every node in a loop will be equal to 0. Then we have Ohm's law, which is just voltage is equal to the current times the resistance. And we use any other derivations of that formula in this lab today. So, and then we have a preview, which is that the node and loop rule obviously are true, and that current is exponential. But let's take a look at the conditions. So we have our system being a circuit composed of a 3-volt battery, a 1 farad capacitor, and 20 ohm bulb. The surroundings is everything else. And our assumption is that we have no equipment faults and that everything runs as intended. Yes, that is what no equipment faults is. So, experiment predictions. My group calculated that the current of the first and second item would be 18.2 milliamps. And yeah, the jury's out on whether that's correct or not. The actual measure that we got, I believe to be, is negative 18.2 milliamps, which is an odd one, to say the least. Then there were a whole ton of different questions that I'll just try and run through quickly one by one, which would be, let me pull out that tab for you guys so that you can see it too. So I'll split screen it. I'll split screen it for you guys. No, not another Google Chrome tab. Okay, so if we are swapping the ammeters, so yeah, that's what this question is. If ammeters are swapped, what would happen? And nothing would change. The current wouldn't change, nor would the volts measured. Then we remeasure the volts, and we get at I1 and I2, and you get 2.9. And then if you were to replace the ammeter with a voltmeter, what would happen? Nothing would change because the voltmeter still has a very high resistance. And then the ammeter reads 0. And then we also left some notes here, which would be our answers to all these little ones right here. Like we have AB is 2.9, BC is 0, AB is 1.98, BC is that. That would represent in our Chrome tab, that would represent these little jumps from A to B, B to C, D to E, E to F for these two. That's how we did it in our group notes. But I've rushed over those quickly because I don't think everyone wants to hear all that. But now for some measurements that we also had, we're using a 3-volt battery and a 1 farad capacitor. And we're changing the bulb each time. With a 10 ohm bulb, the light produced is right at the beginning, and then it begins to dim over time until it goes out in 12.5 seconds. Then when the capacitor is connected directly to the light stays on but slowly dims and goes out at 15 seconds. For a 20 ohm bulb, the capacitor charge took 1 minute and 17 seconds, while our discharge took 41 seconds. Okay, on to the next bit. Possible sources of error. So that can be caused due to human error, missing equipment, or faulty equipment. And then we forgot to scale down the experiment to start. So we were using like a 9-volt battery, and that burnt out multiple light bulbs, but that's okay. Then the what if and why. So I think these what ifs are outdated. I don't know if I grabbed the wrong ones, but what if you were doing the lab in real life? Well, we did. So we know the what if, and that's the what if for both of them. But let's just actually look at the question. So what if, or let's flip it around. What if we were using an online simulator that they provide to us? Well, the online simulator wouldn't account for the actual resistance of the ammeter because it's an ideal simulated ammeter, meaning ideal is it has no internal resistance. So but everything has resistance in real life. So that would mean that some of the results would slightly change due to that fact. So the same thing for the battery and capacitor. They also have internal resistance, and in the simulations, they have 0 resistance. So that would change the time it took for things to charge up, to die, and etc. And then conclusion, keeping human error in mind, the physical principles from the introduction held true. Boom. Thank you for listening.